you. Today I'll be taking another example. So this is a very big data set. So it shows the price of a house, and it also mentions the bedrooms, bathrooms, and square feet living, and all these things. So we are going to find or predict the price, okay, using different models. Okay, so as you know, first what you have to do, you have to load the file to the R then as usual we'll see. So this is the command for the loading the data. So let us see that how to load the. So I'm loading the data to the variable or data frame house underscore data underscore in. Okay, so I have copied that. So total 21,613 observations are there and of 21 variables. Okay, so just type the summary and see. Okay, so I will enlarge this one and show you. So, okay, so this is summary. So you can see regarding each variable. Okay, so this the min, max, all these things. So this is the character one. Okay, this is character one, and that's a numeric or integer. Okay, so I'm just I'll just plot and I'll show you. So this is the plot of bedrooms and price. Okay, depending upon the number of bedrooms and then price. Okay, so just see, I have read some books and then in that they're telling to find the correlation also. So just I'll show you the correlation matrix to. So this is the command for the correlation matrix core. So I'm just taking from the third column. Okay, so I'm removing the these two. I'm ID and date. I don't want. Okay, so I'm making a correlation matrix. This is I'm using complete.obs to discard the NA ones. So if some NA are there, so to discard that NA, for that you are using the use equal to complete.obs. So let us see. So I am making a correlation matrix, and you can see, you can highlight that particular variable, and then again you can type control enter. You can see. So this will be the correlation matrix. Okay, you can see price versus price will be 1. So just if you are taking this one alone, first column alone, you can see price and bedrooms, the correlation will be 0.3. So this is the correlation matrix of this. Some books say now you want to select which all columns to the model. So some books say correlation has to be considered. I will take another video on that. Okay, now I also got some confusion on that, so to select which variables. So I will take the theory part later. Okay, so now let us continue with the programming. So we can see, if you want to see the structure of the data frame. Okay, this is structure. The structure. How? So ID is a number, date is a character. So this is how you see structure of the data frame. Okay, and then now you have to here I'm going to use training data set and test data set. Now you want to partition your data, so you have got the one house underscore data underscore in. It has got 21,613. So I'm going to divide. I want to divide this into training data set and test data set. Okay, so I'm going to make a part 1. Okay, train using part 1 variable. So what is the part 1? It is run if random numbers up to number of rows in the data frame. So just try that. So you can see what is in part 1. Part 1. So it shows random numbers of 21,613. It is showing first 1000, rest they're not showing. So random numbers. So again, I want to know the index of this random numbers. So for that, I'm using the order command. Okay, so I got the index. Why I'm taking the index is I'm going to choose 15,000. So here, if I'm typing, I got the index of the random numbers. Okay, so after ordering, what I did is I made a random numbers of 21,613, and then I ordered that, and then I took the index of each one. Okay, index of each random number, because I'm going to use that for making the train data set. Okay, so this is a command for that train data set. I'm going to read 15,000. Okay, random 15,000 I'm going to read. Okay, for that I'm using this. This is actually for partitioning our data. We are using this. Okay, random numbers and ordering the random numbers, and the index of that order I'm using. So randomly I'm taking 15,000 and I'm making that our train data set. Rest to the test data set. Okay, so let us see. So I'm making the train data set. So I made the train data set. You can click here and then you can see train data set. Okay, so 15,000. Okay, 21 columns, 15,000 observations. I made a train data set. Okay, and then test data. Another remaining I'm using a test underscore data. So now we have to make the model. Okay, so I'll tell you. So we have made the partition. This is over. So now we have to make the model. Okay, so simple linear model, price and bedrooms only. Okay, price and bedrooms, and then summary and box plot. Okay, just to check whether it is normally distributed. Okay, so let us do these three. Okay, or this is important. Let us try that. I am making a linear model. Okay, so I made the linear model. So you can just type. You can see what is in that. So intercept and bedrooms. I use just bedrooms and price only. So price is equal to 11,009. Yeah, 11,9326 into bedrooms plus this interest rate. So that will be equation of the model. Okay, price equal to intercept plus this into bedrooms. Okay, so you can see the summary. Control Shift 2. You can see the console. So this is a summary. So just to get that straight. So this is the residuals, and then intercept, and then 0.9% of the data is explained by this model. Okay, so let us go to the next one. View all panes. So now what I'm going to do is that I'm going to predict the values. Okay, using the training data set. Okay, I can just type the, you can see the box plot also. This is a box plot. So I'm going to predict. So this is the model. Okay, this is the model. We made the model and we are using the data set as the test data, and you are going to predict the values. Okay, you are going to predict the prices using the training data set. You have made a model with the training data set, okay, and that model you are going to use to predict for the test data. Test data is this one, okay. So let us see that. Okay, so here, so you can see, so this will be some values. If you type the, you want to, this will be containing some values, okay. So now I am going to add a new variable, okay, to the test data. So test data is this one, same thing, 15,000, okay. I'm going to add a new variable to the test data dot predicted using the simple linear model, okay. Predict values, so the predict value, so this thing, I'm going to add a new variable to the test data and store the predicted values in that, okay. That's what I'm going to do. Okay, I added a new variable. You can see that new variable would have come here. Test data. So the test data, see, one new variable has come. So this is the predicted value, predicted price. So just take 373748. So here the price was 4260. So there's a difference, okay, the predicted value. So we can find the difference here, okay. Just type the minus and you can see the difference. So now I'm going to the next one. I'm going to use the multiple variable regression, okay. I'll just show you the source window. So here what I'm going to do, I'm going to add some variables to that, okay. So let us take, I'm here adding all the variables, okay. Whatever is there, this you can ignore. I just tried another one more. Here I added bathrooms, square feet living, square feet above, bedrooms, year built, okay. Just ignore that, okay. I mean, I just did that, but let us see taking all the variables. So here I have taken all the variables, okay. I've taken all the variables and made a model, okay. KC underscore house underscore all underscore regression, one variable, one model. I'm making linear model using all the columns, okay, except the first two columns. I'm adding all the things and let us see what is happening, okay. So I made a model with all the variables and summary, okay, summary of that, okay. Let us see the summary. So here 69% is explained by this model, okay. So this NA is coming because this had some NA in that. That's why square feet underscore above had column had some NA. That's why it is coming NA. Just ignore that. You have to correct that. You have to correct the database or clean the data. So this is the summary. This is the model we used. This is the residuals, min, max, everything. And then see 69%. So initially it was 9% with bedrooms alone, I think. Now it has come to 69%. And then I'm going to predict, okay. I'm going to plot, everything is simple plotting only, nothing in that. And then I'm going to predict, okay, predict values using the models. And then okay, predict values using, here I have used the KC underscore house underscore regression. I can use values using all variables equal to just I'm to predict KC underscore house. I'm using this model, and then new data equal to test underscore data. Okay, I'm using this model, what we did now, this model to predict the values. So just that is okay. This one I'm going to predict. So because that NA is there, that's why that warning message came. And then I can add this to this underscore all. Okay, and you can see another column would have been added to the predicted. Okay, this one. Now I added the predicted. Okay, this new variable is added, and then you can see the difference also. Original price and the predicted one, there is always difference is there. And then you can just plot in the difference. Okay, for that I had to use the library ggplot, and then test price. So this is for data frame I am making to plot it different two variables as the new price and the predicted one. So for that I'm using a data frame, and then using the data frame the t underscore d data frame to get it plotted. That's all. Okay, just let us try that. My t underscore d, and then I'm plotting this. Okay, so there is always differences there between the, so first one is var 0. Var 0 is price. Okay, another var 1 is predicted. Okay, so always differences for each id. I have taken the id as the x variable x variable, and I have plotted. You can see the differences. So the conclusion is, what I've done here, I have made different models. With first I made with this linear model, simple linear model. First I did the partition, and then I used price versus bedrooms, and then I predicted the values in the test data, and then I added that variable, simple linear model SLM, and then I used the multiple variable regression. I used this model specifically. I used all the variables, numeric variables, and then I made one model, and then I used that model to predict the values. Okay, and then that model we found it is 69% fitting the data, and then I added one more column to the test data, one more column, and then we saw the difference. So here I used the non-supervised learning method using the training dataset and test dataset. So what I did is I partitioned our data into two datasets. One is for training and one is for test. And training dataset we made a model, and that model was used to predict the price in the test data. So theory part, I have got some doubts. I will say main theory is coming here. Which all variables should be selected here? Okay, see here I selected 1, 2, 3, 4, 5 variables. Okay, and here I selected all the variables. So how you can select the variables, or how you can select which column? See here. Okay. See, price is what we predicted, or we is the initial one. So which all variables or which all columns you selected, that I will explain to you later after clarification. Okay, after I need some clarification. Thank you very much.